Hi, this is the second part of our equations videos using Cuisenaire rods, and this time we're going to be talking about subtraction equations. And for this is a little bit of a different process than it was with the addition equations because it requires the students to use a little bit of mental math first. So the first thing I would have my students do is try to come up with a value here for x that would make this equation a true statement. So 21 minus what value gives us 14? And we're going to prove that 21 minus 7 equals 14. So we're going to kind of go back to the process that we used when we were doing the addition equations, and I'm going to start by building 21. So again, I will use my orange rods, which value 10, and a little white one for the 1. So that gives me a total train that values as 21. Let me move this down a little bit and I will label it. Okay, now we're proving that x is equal to 7, so I'm going to bring down a black bar that values for 7. And I will label this. And if we're in fact correct that x is 7, then this value here must be equal to 14. And we can prove that by using our Cuisenaire rods. And there's a couple different ways that we could build 14. I am going to use an orange bar and our pink or magenta bar to show that this is a true statement. So 21 minus 7 leaves us with a value of 14. And another way that I could actually model it is to take this 7 value and actually put it on top of our 21. So if I took those 7 pieces away, then this is another way of showing 14. And again, I can just take that, put it right on top, and show that that works out. So this process is just a little bit different than how we did it when we were doing the addition equations, but it sort of builds on that prior knowledge. Alright, let's try another one. For our next equation, we have x minus 12 equals 17. So again, we're going to start off by doing some mental math. So the students will have to work out in their head what number minus 12 equals 7. So I believe that the answer is 19. So we're going to see if that's true. Is 19 minus 12 7? Okay, so we're going to start off by building this 19 value, and I'm going to use an orange bar and a blue bar to do that. 10 and 9. So here's 19. Okay, and now I want to take away 12 from 19, so I'm going to build that by doing an orange and a red bar. This is my 12. And if 19 is in fact the correct value for x, 19 subtract 12 should be giving me a value of 7. So we need to see if this little spot right here is in fact 7. And our bar for 7 is black, so let's see if that fits into the right spot. And it does. And just as before, you can basically model this by covering up the values. So if I wanted to say 19 minus this value of 12 right here, just put it on top, and it is in fact 7. Okay, let's try our third example. Okay, for example 3, we have 14 equals x minus 15. So, little mental math. This one's a little bit harder for the students to do in their head. Now, some of you may be actually teaching them how to solve one-step equations, so they would know that they had to add 15 to both sides of the equal sign. If you're not there yet, then again they can use trial and error to figure this out. But I'm going to suggest that our value for x is 29. So now we need to prove and see if that's correct. So what I need to do is model 29 and then take 15 away from it to see if it's 14. So we've got to build quite a large train. We're going to build 29. I need 2 orange bars for 20 and 1 blue bar for 9. This will give me a total of 29. It's a pretty large train. Okay, that's 29. And now I want to take away 15 from that large train, and to do that I can use an orange and a yellow bar. 10 and yellow is 5. And now if I'm correct that x is actually equal to 29, then this missing value right here should be 14, because 14 plus 15 should give me 29. So I'm using some inverse operations here, which is another great skill for students. Okay, so if I'm correct and it is 14, I can use an orange bar and a pink or magenta bar, because the orange is 10 and the pink magenta bar is 4. And that proves to work just perfectly. So this is correct. X's value is 29. So this is just another way to solve equations, in this case solving subtraction equations.